This is pure maths paper 2 from A-level maths 2022. Let's just do it. So this line, 3 minus 2x, has a negative gradient. So this line here is just 3 minus 2x. This line here has a positive gradient. And so what must have happened is this mod must have times the whole thing by minus 1 in order to make it positive. Because that's what the mod function does. If the number is already positive, like 5, it does nothing. 5 modded is just 5. If it's negative, like minus 5, it times it by minus 1. Because minus 1 times minus 5 gives you 5, and you always get a positive number out. So, the line does the normal thing until it reaches a negative place, and when it's negative, the mod just times it by minus 1 to make it positive again. So we times this by minus 1, and we get this. And so now what we have to do is, this is a line 7 plus x, probably looks a bit like this, and we're going to set this equal to this to get this intersection and this solution here, which is that. And then we'll set this equal to this to get this solution here, which is that, and we'll be done with the question. Question number 2, then, you get 2 marks for being able to draw an exponential function. Just know that they always go through 0, 1, because anything to the power of 0 is 1, pretty much. So we get this. It's an asymptote down to there. And then this question here, just take log to base 4 of both sides. I don't understand why this was a question worth 2 marks. I don't understand why they just wrote a paper that's essentially out of 98, because, honest to God, please be able to do that right. A1 is 3. If you just set n to be 1, then you get A2 is 8 minus A1. And A1 is 3, so it's 8 minus 5, 8 minus 3, which is 5. If you set n to be 2, you get A3 equals 8 minus A2, but you know A2 is 5, so that makes A3 3. And then if you do it again, you get A4 is, guess what, 5. And that's enough. You can just say it goes 3, 5, 3, 5. The period of the sequence is 2, because it's every 2 it repeats. Find the value of the sum of these. So this is just A1 plus A2 plus A3 and so on. But A1 is 3, A2 is 5, A3 is 3, A4 is 5. So this is just a bunch of groups of 8 added together. Now the last one is A85. Now that's an odd number, and the odds correspond to 3. The evens correspond to 5. So this last one will be a 3. So you've got 3 and 5 here, 3 and 5 here, 3 and 5, all make 8s. How many pairs of 8 have we got though? Well, we're going up to 84, right, to group the pairs. So that'll be 42 pairs of 8. So let's do 42 times 8, and then we'll add the 3 on the end, and we'll get this number here. Question 4, differentiation first principles is actually in the formula book, because of course it is. So you literally just have to set this equal to f of x, maybe, and then just say, okay, f of x plus h is just this. You just substitute in x plus h into here. You put those things in the formula, so like this. You expand this out, which gives us this. This will cancel with that, which is lovely. The h's will cancel as well, which is even better. And as h goes to 0, this goes to 0, so you're just left with 4x, and we get dy by dx is 4x. Cool. Question number 5 is about trapezium rule, which is, I'm laughing. It's also in the formula book, obviously. And you're even told everything you need, right? A and b is 3 and 9, so we're going to get h is 9 minus 3 divided by n. Now, n is the number of trapeziums you use. There's one between 3 and 4.5, so that's one trapezium here. There's another in between here, another in between here, and another here. So that's 4 trapeziums, so n is 4. So we get h is this. We can put h into there. Y0 and yn are the first and last ones in the table, so they go in there. And then all the others are just the middle ones, and you just fill in the formula, and you get this answer here. This question here, so use log laws to bring this 10 down to the front to get this. And then, of course, the 10 is just a constant and come out the integral. And we know the integral of that is going to be this, very roughly. And we end up with this. Maybe I should have used approximation equals signs here. I don't really care, though. But we get this. And then here, this one's slightly more tricky, but try and relate it back to this. There's a 2x here. There's an 18x here. The most obvious thing to do is just say 18 is 9 times 2. And then you realize, actually, you're timesing inside of a log here. So this is the same as log of this plus log of that, because when you add logs together, you can multiply the inputs. And I'm just doing that backwards. Of course, log to base 3 of 9 is just 2, because 3 squared is 9. Or you can type it in a calculator if you definitely don't know that. And then when we're integrating this, I mean, you could just, there's a bunch of ways to finish from here. But when you're integrating two things that are adding, you integrate separately, right? So I could just integrate this one first, and then this one. But of course, this one I know the answer to is 133. So sorry, no, it's not, it's 13.3. And this is just 2x evaluated between 9 and 3, which I can also do relatively quickly, and I'll end up with my answer. I don't know what this is talking about, or why I managed to I must have just face planted the screen and put those numbers in here for some reason. I don't know where that's come from. Anyway, next one is this curve here, which is modeled with this. Find the x-coordinate of p. Now, p is a minimum or a maximum. It's a stationary point. So we're going to do f dashed of x here. So a half times 8 is 4, and then sine differentiates to cos, and we just leave this alone. 3x obviously differentiates 3, and the 9 goes away, so we end up with this. Now we're going to set that to be 0 if we're looking for a stationary point. Of course, we can add the 3 divided by 4. Cos inverse of that is that. This is in radians, I believe. Does it tell you to work in radians? It does tell you to work in radians. Good. Working in big boy units. Excellent. Anyway, this is not the answer. And the reason for that is this is the first time that cos equals 3/4. And so this must refer to this stationary point here. Whereas we're actually looking for the 1, 2/3 stationary point. So let's get out the cos graph. And what I'm saying is when cos equals 3/4, which is here, this is the solution they've just given us of like 0.7. But actually, we could be over here, or could even be over here, or the next one, or the next one, or whatever. But I think we can count we're just on the third, right? So we're not here, we're not here, we're actually here, which is just 2 pi further than where we were, because it's repeated there at 2 pi. So we just do 2 pi plus this, and then we can double everything afterwards, and we'll end up with this. And I think that'll be the answer. The curve crosses the x-axis at x equals a. Given this, explain why there's a root in between. Well, this one's positive and this one's negative, so it's above the x-axis this way and below it this way. And by the fact that the function is continuous, which you do need to say, it must intersect the x-axis in between. Newton-Raphson is also in the formula book. Here it is. We've already worked out f dashed of x. We've got we've got x0 is 5. So using n is 1, we'll get this. Just putting n is 0 in all of these, we'll get this. That should be a 1 there. No, it shouldn't. That should be a 0 there. Yeah, apologies. That should be a 0 there. So we're going to evaluate f. So x0 is 5. That should be an x0, which makes that a 5 as well. So that's just a mistype. Apologies. x0 is 5. F of 5, we just put 5 into here. And f dashed of 5, we just put 5 into there. You can type that all in one go into your calculator, and you'll end up with this. To 3 significant figures, and you'll be done. Question number 7. Root of this is just this to the power of a half. Binomial series, guess what, is in the formula book. Now, this is the series that you use if n is a whole number, and this is the one that you use if n isn't. So we're going to use this one here. Now, this has a 1 at the front, so if I'm going to use this formula, which you don't have to, by the way, but if I am, because it's here and I may as well, we're going to need to factorize a 4 from this bracket here. And of course, we can distribute this half to both of these two things, like this, and then 4 to the half is 2. So essentially, I'm just going to expand this out using this idea, and then times everything by 2 at the end. So all I have to say here is I'm going to do exactly this, where n is a half, and where x is actually minus 9 over 4x. So we get, the 2 is just this 2 here. Starts with a 1, n is a half, so that's that half there. X is minus 9 over 4x, so that's that there. And the next one is a half minus 1 over 1 times 2, and then minus 9 over 4x all squared. The next one is going to be half minus 1, half minus 2, 1 times 2 times 3, and then this cubed, and then we'll keep going from there. Type in all the relevant things into the calculator, and you get this, times the wall by 2, and you get this. And that's cool, and what we're going to notice here is that these are all negatives, and they're all negatives for a reason, because every other time, this one gives you a negative, because if it's the power of an odd number, this is negative, whereas this is positive, this is negative. But whenever these are positive, whenever you have an even here, there's an even number of terms here, which actually gives you an odd number, a negative number, because this one's positive times by 1 negative gives you negative. So essentially what's happening is either this is negative or this bit's negative, and therefore the term is always negative, which is kind of cool. So we're always taking away here. So this should really be a negative, but it doesn't matter, of course, because whatever. So this is relevant for this bit. State whether this is an overestimate or an underestimate. Now, what I've done here is if I'm cutting this off here, is I've removed a bunch of negative terms. So this answer should be bigger than what I've got. Sorry, should be smaller than what I've got. Imagine taking away 1, 2, 3, 4, or whatever. If you just ignore that, you're making this thing here bigger than it should be. So this is an overestimate for what it should be, and we'll just say that. You didn't even need to justify that. I don't think you just needed to say overestimate. Anyway, this one here, we're finding the area R, so let's make this integrable. So let's expand out the top bit, which makes that. Then let's divide each term individually by this. 1 divided by 4 is a quarter. X squared divided by x to the half, you take away the powers, you get 1.5 or 3 over 2. Same here, 6 over 4 is 3 halves. 1 take away the half is a half, and then this is x to the 0, I guess. So we just make x to the minus half. Now that's integrable. However, I don't know where to integrate it between, so I need to set y equal to 0, because y is 0 on this point and this point. So set y equals to 0 times by this both sides, it just goes away, you get this. You could expand this if you really wanted to, or you could not be a dummy and just realize that this is already in the form you want it. X is either 2 or x is 4. And so this is 2, this is 4. We're going to integrate this between 4 and 2. And again, raise that up to 5 over 2, divide this by 5 over 2. You can use a calculator for this. Raise that up to 3 over 2, 3 over 2 divided by 3 over 2. I hope we know is just 1. Raise that up to a half, 2 divided by half is 4. Put the numbers in, and we get this. You can put this in a calculator. It will give you this stuff. If you want to be more intelligent about it, you can do. I was, because I don't generally have a calculator very close to me, aside from my phone. But 2 rooted is root 2 to the power 5. Root 2 to the power 5 is 5 root 2's multiplying, and each pair of those just makes a 2. So you've got 2 pairs of 2 and then a spare root 2, which gives you 4 root 2, and then you divide by 10 to get this. So that's one way you could think about it if you desperately wanted to. Otherwise, you just do this and you get this. Now, one thing to say here at the end, I'm pretty sure, looking at the mark scheme, that gets you full marks. It's not really the answer because this is negative, and area can't be negative. It's just when you integrate a curve, you always, by default, get a negative answer if the curve is underneath the axis. So I just flipped this over to give myself a nice positive number, and this is now a proper area, right, because it's positive. But I don't think you needed to do that based on the mark scheme. This is the first of 2 really stupid questions that I just think there was somewhere in here that's a decent idea for a question, and it was just very poorly executed. So the maximum height of the passenger above the ground is 50. Okay, well, the biggest sine of anything can ever be is 1. So if h is going to have any ability to get to 50, then a must be 50. And so we say it's 50, because it must happen when sine of this is 1, and then 50 times 1 is 50. Likewise, if it takes 720 seconds to do a kind of a rotation, which is from here to here, because I think this is plotted 1 rotation from here down and then to there again. Well, sine usually does a whole rotation every 360. Sorry, no, it doesn't. It usually does. So sine usually does its up and down bit. Like it gets to here and here in 180 degrees, doesn't it? Because it's like 180 to there, then 180 to 360 there, and then it does another thing. So it usually does this in 180 degrees. It's apparently doing it in 720, so it must have been stretched out by factor 4. So b, I think, is a quarter, because when you do a quarter x, you stretch the graph out horizontally by factor 4. So I think this graph, to make this 720 when it should be 180, the graph has been stretched out factor 4. So I think b is a quarter. And from here, this is actually very straightforward once you've realized those two things. Because if the passenger is 1 meter above when the wheel starts turning, that means h is 1 when t is 0. And you can use a as 50, you can use b as a quarter, and you can just shove, and of course when you put t as 0, the b doesn't even matter, and you get this. Technically there's a mod here, but I don't care. And you get this, and then you get this when you put that in a calculator, I think. Does that seem reasonable? Yeah, why not? And you get this as your answer, I guess. Yeah, I didn't. The reason I don't like this is because this doesn't make any sense as a model. And this is what this is about to talk about, is apparently it starts when h is 1. So like the wheel is a meter high when you get on it. But apparently later it gets to h0. So this is a weird Ferris wheel that you get on 1 meter above the ground. And then somehow later it drops to the ground before rising up again, which just doesn't make any sense. Anyway, this is more appropriate because it means the Ferris wheel never hits the ground. And I spent a good couple of minutes wondering what on earth was going on here before I just read this question and realized that it's deliberately bad on purpose, which I just don't understand. Why would you do that? Anyway, the next question then is f of x equals this, find this. Now you could find the inverse function for f. I didn't. I just said let f inverse of 3 over 2 equal y. And now this is a bit like sine and cos, right? Like if you've got sine of y equals x, you could just flip the sine to the other side and do sine inverse. So I'm just going to flip the f to the other side and do this, right? It works both ways. You can send f inverse to f if you just flip it to the other side, just like you can flip sine and cos either side of an equals. So we get this, we just put y into here to get this, cross multiply and solve, and we get y as that. And that, of course, means if I let y to be that in the first place, that means that's the answer to my question. Show this thing here, so you could do some polynomial division here if you wanted to. I don't even know what this line's about. I think I thought about doing something before, and then I realized it was dumb, so ignore this. What I actually thought about doing was this. Now, again, you can polynomially divide and just immediately end up with a is 4. But I decided to just write this as 4 lots of 2x plus 3. That makes a plus 12, so I have to take away 7 to make this balance. And then, of course, I can split the fraction here to make this, because you just bring those fractions together because they have the same denominator. And then this is just cancels, you get 4 minus this, and that would be the answer. The function g is defined by this with the domain of that. Find the range of g inverse. The range of g inverse is the domain of g. So the range is just between 4 and 0. Find the range of f g inverse. Now, I went to way too much effort for this. I actually thought about finding g inverse, so I did the same thing as I did before. Let g inverse equal that, swap the side of the g, put g of y into here, or evaluate g of y, I guess, and then rearrange for y, and you get this, and so therefore that's what g inverse is. And then what I did was I put g inverse into f, so I put this thing in every time I saw the f, and then remembered that they'd already told me that f could be written like this, so I wrote it like that. I just wrote it like this, with x as that g inverse of y thing. And then I thought about this long and hard and decided, okay, what's the biggest and the smallest that could be? Because that's essentially what the range is what's the biggest and the smallest the function can be. Now, we have limits to what we can put into g inverse in the first place. Like sorry, not what we can put into it, but g inverse can only take values between 0 and 4. So if g inverse is 0, let's just make this 0 here. We get 4 minus 7 over 3, because this whole thing is 0. And 4 minus 7 over 3 is therefore going to be the lower end of what this whole thing can be, because 7 over 3 is quite a big number to take away. Whereas if you make g inverse be 4 and make this a 4, you get 7 over 2 times 4 plus 3, which is 7 over 11, which is a smaller number. 7 over 11 is a smaller number to take away from 4, and therefore you're going to get a bigger number in the end. And those are the two limits we can put in. And notice how I didn't even need this root 16 minus x thing. I was just evaluating the 4 and the 0. So I didn't need to do any of this. I could have just put 4 and 0 into here and worked out what the biggest and smallest is, which turns out to be this when you actually evaluate those fractions. But anyway, yeah, kind of an interesting question, I guess, in some ways. Show this is even for all n. So we'll start with n as even numbers itself. So n is 2m, put 2m into here. This is obviously even because it's 2 times something. You don't even need to write that next line out. So that's done. Next, show that what happens when n is odd. So we'll write it like this. We'll put those things in here. We can square that out. It's going to be 2m times 2m is 4m squared, plus 2m times 1, plus 1 times 2m is 4m, plus 1 times 1 is 1. Add the 1 and the 6, 1 and the 5 to make 6. Just factorize out a 2 from this, and then this is 2 times something. So this is even. And we're done. So and you just write a quick sentence that as the result is even for both odds and evens, it's even for all n belonging to the natural numbers or whatever. Something like that will get you up. The function is defined like this. Show this thing here. Quotient rule is in the formula book. You can use it if you want to. It's useful for me that it's in the formula book because I never ever use quotient rule. I don't understand why anyone does. You can just write this as this to the power minus 1, and you can just use product rule. So we'll differentiate one of these first and leave the other alone. So I'll differentiate this one first. It looks like put a minus 1 down here. Lower it to a minus 2. Differential of this is 8x. So that goes at the front as well. And then leave this one alone. And then next, you differentiate this to make 3 e to the x, and you leave that alone. And now we've just got some work to do to make it look like this, I guess. We can factorize out 4x squared plus k to the power minus 2, which just leaves behind this here. That's all there's left behind there. And then here, I just need an extra 1 here to make minus 2 plus this 1 here be a minus 1 there. And now I can also factorize out e to the 3x. And I actually, guess what, get exactly what they wanted me to get. And so therefore, this term here can be written as the g of x. And I think we're done. The curve has one stationary point, so therefore this is equal to 0 somewhere. Now, if that's equal to 0, that means it's a product, right? So either this thing is equal to 0, or this thing is equal to 0, just like it is when you do like factorizing. Now, this thing is a product in itself, right? It's this thing times this thing. So either this thing is 0, which can't be the case because we drew an exponential graph earlier on today, and we know it's never 0. So that means this thing is 0, but that thing can be written like this, and this is never 0 because you times over both sides by this and you get 1 equals 0, so that's not going to work. This, of course, can be 0. It's got solutions when b squared over minus 4ac is greater or equal to 0. It's at least one stationary point, so it could happen more than once. Anyway, b is 8, or minus 8, I guess, but you're going to square it, it's not going to make a difference. A is 12, and c is 3k. And yeah, you do some stuff and you get this. K is positive. I don't think you lost marks for leaving it there, but K is positive, so you might want to write it like this in the end. 13 then is a vectors question. I was pretty bored at this point in the paper, so I decided to draw this. What I decided was if these 3 vectors are on a straight line in 3D, then that means they must be on a straight line in 2D. So I just literally ignored the K's, literally crossed them out. I just ignored the k's and said, this is position 4 minus 3, which is down here somewhere. This is position, starts with a 0i, look. So it's 0i4j, so 0i4j is up there. and this is the position vector minus 16 plus pj. Now, if this is in a straight line, to go across here, you go across 4, and to go up here, you go up 7 from minus 3 to 4. So if we have to go another 16 across from here, and we want to be in a straight line, the gradient is 7 over 4, so we rise 7 every time we run across 4. We're running across 16, so that's going to be 4 lots of 7 we're going to have to jump up, and we'll add on this 4 because we'll be starting there. So it'll be 4 lots of 7 plus 4, and we'll make 32. I think that would be the answer. The line segment OB is extended to D. So they take OB, which is this, and they multiply it by something to get it as far as D. Right? They just make it longer by some factor. Now CD is equal to, imagine, so this was A, wasn't it? And this was B in 2D at least. So that means A to B is minus A plus B. So C to D is minus C and then plus D. Now minus OC is just this with the things flipped over. I'm doing everything in columns because it's easier in PowerPoint. P is 32, remember. And then O to D we've already said is this. So we'll add that in. We can put these together to make this. And now that's parallel to OA. OA is this. So if these things are parallel, that means you can multiply this by something to get to there. But I can see I must have to multiply it by 4. So therefore, minus 3 times 4 is that. And we can solve for k. And you can verify that this times 4 is this for the same k value, right? This times 4 is 20. And so if this is to be 20, then you add 10 to get 30, divide by 6, and you get 5 as well. So k is definitely 5. You put 5 into here, you get O to D as this, and then the length of O to D is just Pythagoras, and we get that in the end. Good. Question number 14 then, so make that into partial fractions. I'm hoping we can all do this. You just put this there and this there. I think I set x to be minus 1 to start with to make this go away. That becomes a minus 3, then b becomes minus 1, and then you can set x to be a half next, which makes 1.5 here, which makes a 2, I guess. So the answer is going to be this. Good. Now we've got a differential equation to do. So 3v over this is just this times by v, right? So I've just sort of factorized out of v to the front here and then replaced this with this partial fraction here. And the reason I'm going to do that is because now I can divide both sides by v and times both sides by dt, and now it's separated. And now I can just imagine integral signs on both sides, integrate this for log v, integrate this for some more logs. Yeah, that looks good. I think I actually fluked this. Anyway, so of course, just check. The derivative of this, when you derive a log, you put this on the bottom, and then the derivative of this is just 2, so that goes on top. So this just matches perfectly. So I think we're just done. Plus c, of course, because we've integrated. You know that when t is 2, v is 3. So you put that information in, and you get c is log 3, I believe. So I'm just going to write this line out here with this as a log 3. And then, of course, we can follow log laws where you can't just cancel out all the logs right now. You need to put them all into one log. So you do this divided by this because it's a minus, and then times by this because it's a plus. And now we can cancel the logs, and we end up with what they wanted us to get. Apparently, there's a time delay before any oxygen is produced. V is the oxygen produced. So apparently, time starts, and then there's a bit of a wait, and then the V starts getting bigger than 0. So let's just look for the time when v is bigger than 0. So I want v to be bigger than 0. So I just want this to be bigger than 0. And I just want to find the time in which that happens. Times by t plus 1 doesn't do anything. Solve this and you get t is greater than a half, I guess. So the time delay is half an hour, which is 30 minutes. The limit, so as t gets really, really big, imagine throwing in a massive number into here. You just have 6t on the top and t on the bottom. The t's cancel and you just left with 6. The minus 1 and the plus 1 just become irrelevant, so the answer is just going to be 6. Question 15, then, this is a geometric series, so if you times this by something, you get that. Now, what do we have to times this by to get that? Well, we can just do this divided by that, because if I times this by that, this will cancel with this, and I'll just be left with that. Likewise here, I'll just do this divided by that. Now, if this is a geometric series, then the thing that you times by every time is the same, so this must equal this. Okay, and now we can cross multiply, and I've also written tan as sine over cos, which is convenient because this cos will cancel with this cos, and we'll get this. I've also expanded this out on this side over here to get, remember it's this bracket times itself, so it's 25 plus 10 sine theta plus another 10, and so on. So we get this, we can move that to the other side, and we get what they wanted us to get. So we're working in big boy angles, that's good. Solve the equation in part A. So we're solving this here. You can actually just notice that this factorizes if you want to. You could make a substitution like y equals sine theta and then use the formula or whatever. It does just factorize though. So we either have that this is 0 or this is 0. This doesn't go very well because that's way bigger than 1, so we'll ignore it. This makes sine theta as a half, which makes theta pi over 6, 30 degrees if you're working in euros. And that's not the right answer, because it says that the angle is obtuse, which is bigger than 90. So we'll get out the sine graph and we'll say, okay, well, they've given us the value here of pi over 6. I don't want that. I want this one over here, which is just going to be pi minus pi over 6, which I believe is 5 pi over 6. And that will be the answer we use. Show the sum can be expressed in this form. So what I'm going to do is I'm just going to use 5 pi over 6, and I'm going to put it into all of these terms to make this the sequence. And I can also put that into there to work out the ratio is this, or you could just use these numbers. It doesn't really matter. The first term is this. The ratio is this. In your formula book, you have a formula for the sum to infinity if the size of the ratio is less than 1, which this is. And so, yeah, I think we're good to go. We just put these two numbers straight into there. I literally typed that into a calculator, and it gave me this, and then I factorized out 9. And I should have put a 9 here, but I think I've said clearly k is 9 here, so I think I could probably get away with that. Anyway, we're good to go. Question number 16 then is parametric equations. Show the equation for L is this, so we need to find the gradient of this curve at this point here. So, okay, let's work out dx by dt first. Everyone knows tan differential is x squared, so that's pretty easy. Differentiate this one here, and we get, now what's the differential of sec squared? What I decided to do was write that as cos to the power minus 2, because the minus will flip this over to become a sec, and then it's sec squared, right, because it's got a 2 there left over. Now I can differentiate using the chain rule. The minus 2 comes out to the front to make a minus 4. That drops to a minus 3. And then the derivative of cos is minus sine. So we make this here. Now, why is that helpful? Because I want dy by dx. But by chain rule, dy by dx is dy by dt times dt by dx, because these t's would cancel and just give you this. And so if I flip this one over, now this is essentially 2 over cos squared. So flipped over, it's cos squared over 2. And we just need to times this by this. The negatives cancel. 4 divided by 2 is 2. Cos squared, and then this is cos cubed on the bottom. Just leave 1 cos, they'll cancel, and you just get 1 cos on the bottom, and then sine over cos is tan, and we just end up with 2 tan t. Evaluated at pi over 4, or tan of pi over 4 is 1, so we just get 2. And this is a normal, right? So the gradient of this normal is the negative reciprocal of that, which is minus half, so looking good. What I'll do is I'll put in t as pi over 4 into both of these, just straight in a calculator, and we'll get these two values. So therefore I can use y minus y1 equals mx minus x1 with my gradient, the negative reciprocal of that, and x1 and y1 being these two things. And if I sort that out, I get the answer that they wanted me to get over here. Good, the next bit then is show that we can write all points on this curve like this. So just take the x thing that you have and slowly turn it into this. So let's take away 1 first from here. That just cancels that one, so that's nice. Then let's square both sides here, we'll get this. Then let's halve both sides, we'll get this, and then let's add 5 and we'll get that. Now let's work on the y. So y equals this, and my aim is to turn this into that. The sec squared is the obvious thing to change. We all know this, of course, and what we can do is if we divide everything here by cos, sine squared over cos squared is 1. Cos squared over cos squared, sine squared over cos squared is tan squared. Cos squared over cos squared is 1. 1 over cos squared is sec squared, and so I can replace that sec squared here with tan squared plus 1. Expand that out, and you immediately get this, and so therefore, because they both equal that, this here is equal to that there, and we'll be done. And next and lastly, the straight line with equation this has intersects through its two distinct points. Now there's a few things to be sus of here, because it seems pretty obvious that you can just set that equal to that and say, well, if it intersects at 2 distinct points, you want b squared minus 4ac to be greater than 0. So I'll just rearrange this. I think I just times everything by 2 here, and I'll just look for b squared minus 4ac greater than 0. 2 things to be sus of here. Firstly, this is out of 5 marks. In fact, 3 things, because I just thought of another one. Firstly, this is out of 5 marks, and you are not going to get 5 marks for doing this, right? Secondly, it's the last question on the entire A-level maths paper. It's not going to be a discriminant check. And thirdly, we had a discriminant check earlier on the paper. So what's going on here? Why is this only 2 marks out of 5, which is how much it is? Well, it's because this curve C is not this. Every point on C behaves like this, but C is not this because C stops here and stops here, right? This curve would go on forever. And what this check has done is it's checked this line against the curve that would go on forever. Whereas this curve C doesn't do that. It stops here. So for example, so all of these lines here have gradient minus half, so they're parallel to the one that we were looking at earlier here. this is a good this is a good answer, right? So there are k values that do work. This has two solutions here. But like if you just make k really, really big, like for instance, if you made k 17 over 2, which is a bit bigger than this, you don't have two solutions, you only have one. Because the second solution that you would have over here, you don't, because this curve stops here and here. So what we need to do is we need to bound this by something above. We bound it from below, and now I think this is a good answer so far, because what this shows is what k has to be to just have a line go through it twice at the bottom here. But we need to bound this k somehow. Look at this, k is the y-intercept. So essentially I just need to, there's a point where if I move k up too high, I end up going over this point here, and I only end up with one solution again, just like this line. So how do we bound that k? Well, let's just look at this point here. Right. Where is that point? Well, t at its lowest is minus pi over 4. So let's just put in a calculator minus pi over 4 into both of these equations here, and we end up with that. And so I think the largest or the highest line that we can have that touches this curve at 2 points is the line with gradient minus a half and goes through that point. So I'm just going to do some this line here essentially. I'm just going to do some y minus y1 equals mx minus x1 with this point here and this same gradient, and I'll work out this. And so I think that's the biggest thing that k can be to still have two intersections, any bigger and you're looking at a situation like this line. And this is the smallest that k can be, because that's what correctly found the line at the bottom here by doing normal discriminant stuff. So I think we have this here. We can be equal to this because, of course, we can go through it on it there. And yeah, I think that's the whole paper. Thanks for watching. I'll see you next time.